brand new class. The things that we very much wanted to put into your hands was to go over the vehicle to make sure everything was hooked up and installed properly. We've inspected every vehicle, gave them a clean pass, and a lot of them, once we got them on the dyno, we found additional problems that did not show up in a preliminary check. As an installer, that should tell you, prep my customer so that when I come back and say, look, the O2 sensors looked fine when I did the little test drive around the block, but once I got it on the tuning process, they just were not responding properly. I'm going to have to put new ones in or whatever. So prep your customers. You may wind up having to put something else in that did not show up on a preliminary check. We're going to work on a checklist that we're going to try to get into your hands, things that should be checked before you start a tuning process. Perhaps things that should be checked before you even commit to an install. I think you guys have seen how easy it is to miss small things, not just with the vehicle, but we've had a lot of vehicles come in where there was only one thing wrong with the install, but that one thing was what kept it from being tunable. That one thing kept the mileage elusive on that vehicle. We wanted to show you AFRs, and we pulled 2 AFRs. I thought we pulled 2 AFRs up on here. The Camry, there's an ECU issue. We unplugged the oxygen sensor. We did not trip a heater code, nor did we trip an O2 AFR code. The computer's not recognizing that AFR sensor at all. You cannot tune it if the computer doesn't see it. And it goes back to, you cannot tune anything if it's an open loop. Well, the computer's not looking at it in open loop. In this case, the computer wasn't looking at it at all, no matter what. Then we pulled the Tundra up, and we had a bank 1 sensor putting out 0.00 volts. No codes. But we still want to show you guys tuning an AFR before you go. So if that's on your list, it's already been said. We may or may not have any wide bands here. Would you go over that 2.5 volt ground reference on the Chryslers for everybody? What did you do to get that tuned?
Well, what we did, first of all, on the PT Cruiser. Okay. I used a different strategy on that. First of all, I went in and we tuned the map sensor. We did a map adjust on it. We did verify under load, ignition timing, and injector pulse width before the map adjust. And then with the Ohm Ranger, we actually added resistance to the circuit, and I was able to take away fuel from it in a manner that totally affected the drivability. So we would play with it until we got our injector milliseconds to go down, but still not affect our horsepower under load. And I think we ended up taking about 4 milliseconds off under load without affecting the drivability too bad. Now, Roger did what he did is on the optimizer ground, he put a 2.5, he changed the bias voltage. He put a 30 ohm resistor on the ground to the optimizer. Excuse me. And now under load, I still tuned the pot, and we were getting pinging. So now what I basically did, because we used the map sensor to take away fuel, I tuned the pot. It was pinging and when I would go one way, and I turned it to where we got our fuel balance back to where we weren't getting no pinging, and you could feel that power balance come back in, and you could see our voltage on the scope where we needed to be. And that's how we addressed that one. Roger's gonna go drive it now and make sure that we don't have any drivability problems. But when you see actually data on the scanner, That's just assurance that you did do what you intended to do, because you've actually seen the data change. I think that's just another good tool if you guys understand what you're looking for. And I hope I covered everything with you guys out there on the dyno, what we're trying to accomplish out there.
Now, when you put the 30 ohm resistor in the ground wire, that raised the whole ground circuit of the optimizer.
Yes.
By raising the whole ground circuit, the single wire going to the coolant and air temp sensors is basically a resistor that goes between the signal wire that we splice into and ground. And as long as ground was the same ground that the sensors were referencing, all was well. But now that we're raising ground
Right.
2.5 volts, instead of going a resistor to ground, now we're going a resistor to 2.5 volts. So you eliminated those portions of the circuit, right?
Yes, he ran his own separate.
By going in and tuning with the map adjust, lean limits no longer became an issue.
Right.
You were able to take the fuel away simply by taking the fuel away at the map.
Right.
You didn't have to alter coolant or air to lower lean limits. So those portions of the circuit were removed. Yes? Is there more?
Yes, I'll give you an example. Your little P6 terminal, the voltage inside, this is how you can tell that we did affect that voltage. Okay, if you use the actual ground off the battery, not the ground inside the optimizer, because the ground inside the optimizer was raised to 2.5 volts. Just as an example, what we did to verify this was we went and we put our voltmeter ground on the battery, not the optimizer ground. Our P6 terminal was reading 3.85, I think, volts. Okay, now our internal voltage when we used our ground terminal was still reading 0.3. But if we used the battery voltage, the car's ground, we were reading the 3.8, which if you do the math, you add the 0.3 plus the 2.5, that's where we're getting the 2.85 volts.
Does everybody follow that?
I think that you had said 3.5 and not 2.5, which it was.
Well, run the math, and that's, he said, I think it is, but 0.3 plus 2.5 would be 2.8, 2.85. Yeah.
It was
Okay.
2.5 and then the 0.3 made it to be 2.8.
The internal P6 voltage was we ended up, because it's a turbo car, we had to leave that one on the rich side. It was 0.3 something was the internal voltage, plus the 2.5 was gonna be 2.8 something volts. Just to throw that out there so you guys can understand it better.
Does everybody understand that? If anybody does not, say something now. This is a, yes, sir.
The temperature circuit in that car there, I was able to put potentiometers in there to adjust, you know, with the signal return for the temperature separately. It was not connected
So
to
you
the
put
operator.
external resistance
I put
value
external resistance.
across the air temp, coolant temp, whatever, to
to bring it into the parameters. That
bring it into parameters. Okay. Any other questions about the later model Dodge floating ground oxygen sensor fix?
Maybe an explanation on why that it was necessary, what happened before.
Okay, why was that necessary? Dodge is taking a plain oxygen sensor in concept. It works from 0 to 1 volt, the same as all oxygen sensors for the past 20-some years have done. But instead of that 0 to 1 volt being referenced to the negative side of the battery, chassis ground, that 0 to 1 volt was elevated by 2.5 volts. So it was 2.5 to 3.5 volt range. It had a 2.5 volt ground reference. That 2.5 volt ground reference being 2.5 volts above battery ground. The optimizer, when the negative wire is hooked to battery ground, has a 0 to 1 volt operating range characteristic. And with 2.5 to 3.5 volts going into the optimizer, it's always going to just read 1 volt, or 0.9, 0.95, whatever. So we no longer have an operational circuit. we can still use it's as if we took, from 0 to 1 volt, we just shifted it by 2.5 volts. The relationships are the same, it's just 2.5 volts higher. So by taking the optimizer black wire and elevating it by 2.5 volts, essentially adding a 30 ohm resistor in there. Now that worked on this particular car. You might be able to take a map adjust circuit. The type that uses the LM317, use a map adjust circuit. It'll go from like 1.6 volts up to 6.5 or 7 volts. And if you were to turn that down to 2.5 volts and then feed your black wire from the optimizer to that, you could accomplish basically the same thing. Because you've elevated the ground circuit in the optimizer to equalize with the ground reference going into the oxygen sensor on these newer Dodges. Once you do that, then everything's just 0 to 1 volt, 0 to 1 volt above that. Now, again, your temp circuits on it, I mean, if you use this with the 4X, you have 2 wires for the coolant, 2 wires for the air. And that elevated ground makes no difference. The internal circuitry in the optimizer operates off of 5 volts. So as long as we have more than 5 volts that can be regulated down to 5 volts, we're good. If we have 12.0 volts off the battery, and we raise our ground 2.5, that means we still have 9.5 volts that the optimizer can generate a 5 volt reference with. So we didn't alter the circuitry in the optimizer. It still performs the microprocessor's happy because it still gets its 5 volts. But now we can go in and tune an oxygen sensor that has a ground reference at 2.5 volts above battery negative. Does that answer your question? Are there any other questions on this?
Basically, I want to cover something that I think that needs to be done. Oxygen sensors nowadays, they're pretty widely changed from year, make, model. I think that you need to familiarize yourself. Even me, you guys see, I think I'm a pretty knowledgeable person, but you see even me double checking my own self. Having good information, doing your homework on that vehicle before you go and just start plugging into it, I think makes a big difference. When I'm checking a vehicle, you guys were around, I would definitely read theory and operation of what kind of sensor we're dealing with, what kind of voltage we're dealing with. Now that you guys got a better understanding of electronics, now you know how to address those voltages and how to change them. If you go in there just saying that it's a regular O2 and you start cutting and snipping, and that doesn't necessarily mean that we're doing what we're supposed to be doing. We've seen that here I don't know how many times. I had to plug in the scanner and my data was way off. Double check the wiring. It was supposed to come in for tuning and it was wired in properly. So familiarize yourself with what you're working on. Read theory and operation on the sensors, how they work. And that's what I wanted to cover.
Did you say wired in properly or in properly?
Wired in properly.
Wrong?
Right.
Wired wrong was incorrect.
No, wrong. Not right, wrong. Yes, sir.
I'd like to address that issue of they're wired right, but just no connection. That Lexus that we worked on with the oxygen air coolant sensor wasn't reading.
Yes.
It was a simple blue connection, the T connections where you don't want to cut your line, you just want to T into it. It's supposed to strip back the insulation and make a connection.
Right.
They're garbage. And throw them in the garbage and don't even use them. Either strip the wire back, make a soldered connection. My choice would be to cut the wire, soldered connection, and put your shrink tape on or heat shrink on it before you make your connections, and you get an absolute connection.
If you guys are doing installs, I totally agree with that. If you guys are doing installs and you use those T-tap connectors and it's exposed to weather, that's a very good possibility why that your customers are getting savings for a month or two and then they come back and say, well, they're not. That's a self-inflicted gunshot wound, really. That's what I call it. I mean, you're putting yourself into that situation. Try and take your time, especially until you guys really get used to installing these on quality, not quantity. Quality is a big issue, in my opinion. As good as I think I am, I sometimes take a good 8 hours to do an install. That's fabricating brackets, double checking my wiring, and I haven't had to fight with too many of them. And I think part of that is because I take my time. I route everything properly.
You want another good advice? You open up a wire, you want to splice it, make a point, go right through the middle of it. Put your wire through there and then solder it. You're not going to get any resistance. If you just wrap it around and solder, your solder can give you resistance.
Repeat that.
Okay, the last two comments from the class, for the sake of the camera, based around wiring issues. The first comment said about those little blue clips, you slide them over the wire, take a pair of pliers and squeeze. You get a lot of electronic kits that include those in the kits. There are none of those in the optimizer kit, nor will there ever be. The best thing to do is to peel back the insulation, solder it, maybe even cut the wire so you can fit heat shrink tubing over top of it, and then re-splice everything together with solder, slide your heat shrink tubing up, and get yourself a weather-tight seal. The quality is make it or break it. One thing that we've learned in the last 4 days is the vehicles that have been brought in that were supposed to be ready for tune, the installs were done, the installs were working the way they were supposed to, it was just a tuning issue. How many have we had? Has there been one that was ready to tune? I don't see any hands. There weren't any in the first class either.
Listen, in the range that we ran into dirty fuel cells, that really concerns.
Yes, another thing that we are finding time and time again, apparently stainless steel has impurities in it. When we put an electrolyte in a fuel cell, even made of stainless steel, and we apply a voltage bias between the plates, it's similar to an electrolysis process used to plate nickel, copper, chromium. The electricity will pull out the impurities in the stainless. So if I'd take a syringe, put it in a fuel cell, pull it out, take a look at the electrolyte. A lot of times it's dirty. There's even black particles floating in it. A lot of times I pull it out and it looked clean. I just work that a couple of times to flush the crap off the bottom, and then it gets dirtier and dirtier each time I pump it. Perhaps we need to make an appointment with our customers 2 weeks to a month after the install, remove the fuel cell, and thoroughly clean it out. Thoroughly clean it out would be start out with dumping it out and then using tap water, fill it, shake it, empty it. Fill it, shake it, empty it. Now on the older fuel cells you have a dry side and a wet side. You want the wet side down. So you turn it this way, you fill it, and then wet side down, shake it back and forth, because the small holes between the plates will allow sediment and whatnot to work its way down into that wet side, so when you turn it upside down to empty, it'll get out. If you turn it with the dry side down, then whatever's in the wet side will work its way in between the plates, and it may put out less than before you ever touched it. After it's coming out good and clean, then put a little bit of vinegar in there and work it around. Because the fuel cells are caustic based, vinegar is a mild acid, and anything that the plain tap water couldn't get out, the vinegar will dislodge chemically and help to thoroughly clean the plates even further. Rinse it out a couple more times with tap water, then do a final rinse with distilled water. Reinstall it and go through the charging process again. Get your 15 amps with no bubbling if it's an old one. The newer ones, you tune it for 15, 30, or 20, or whatever you're targeting. Pretty much every one of the fuel cells came in dirty. We just learned something. They need to be clean.
Is there a concept of using hot water to flush them because expansion qualities? Cold water, hot water? We used to flush heater cores out, and if we didn't want hot water through them, you didn't flush them. You gotta get it up to the same temperature as what it is to dislodge them.
Okay, the question is hot water or cold water? Don't have an answer that one way's better than the other. It was just this week that we realized the magnitude of that dirty fuel cell problem. So we don't have those answers yet.
The vinegar should address that temperature problem.
Yeah, you're going in chemically doing what could be possibly done with temperature.
Does this something have to be done periodically?
I don't know. What would be nice is if we saw some of these fuel cells that were already run, thoroughly flushed, and then see them again in another month or two to see what the electrolyte looks like then. Don't know the answer to that one either. If you have an HAFC kit on your own personal vehicle, monitor it. Give us some feedback. Let us know if we got 10 people saying, no problems, I flushed it once and it's good. And we got one person saying, no, it was dirty again. Well, that gives us an idea of what we're dealing with. Well, is it dirty again because that was a dirty batch of stainless? Is it dirty because the water that one person used is different than the water the other 10 used? Or is it dirty because the cleaning process done the first time wasn't as thorough on that one as it was the other 10? But at least we now have something to look at. What else have you learned that you're really excited about, that you're happy that you got it? Joe?
Keith.
Keith.
Before
I called you Joe on one of the previous videos too, didn't I?
I'm not sure.
Keith.
Yeah, anyway, about the contaminant that's inside the fuel cell, you know, we dump it out, the black stuff, it's been brought up that it could have been from the plug that's going in. But couldn't we, like, save some of that stuff we get out of some of these fuel cells and get it analyzed by somebody?
You're welcome to.
Okay.
It's not the plug. I don't think it's the plug, because I got the one with the new one with the plastic bottle, and we put it on, and on the run up here, it turned black, and we flushed that before we put it on. So it's only been on for
Okay,
2 days.
we know we're getting contaminants. Is it from the stainless? Is it from the rubber plug? We don't know. We know we're getting contaminants. It's obvious we need to plan on doing a flush on the fuel cells. Yes,
Maybe
Keith.
it'll tin and it won't stop. Maybe it'll tin itself and it'll stop, maybe.
That's what I'm thinking.
You know?
Have we been getting
For the
getting
first
the
few
same problem with
times,
the double fuel
and then
cell?
it'll go away.
The double one is just sandwiched together. There's no welds.
They're too new. The double fuel cells are too new. None of them have been in, I don't think we had any in here.
Mine's a
That's what I was
double.
thinking.
How long has it been on?
About 3-4 days, maybe.
Yeah, 3 or 4 days isn't long enough to really tell. We're seeing ones that have been on for 2 months. Art's, our cameraman's, was on for 30,000 miles now. Yes, sir.
I put a double fuel cell on about 3 weeks ago on an Astro van, and within a couple of days, that electrolyte turned milky looking. Just
Okay, so we're gonna have some problems with the double fuel cells too, that they need to be flushed. Nice thing about the double is you can take the nuts off and you can separate the plates and you can do a much more thorough cleaning of the double fuel cells. The older single ones, everything's welded together. You cannot get access to it. So, something to consider. It's a little easier to do a nice thorough cleaning on that. Empty out the reservoir, rinse it out, pull the plates apart, clean between them. Just be careful when you put it back together, you get the rubber O-ring in there, it's not overlapping. Make sure that the plastic, there's a little lip that goes down in, make sure that it's all seated properly. And they pressure test everyone back here before they ship them. If you have a way of putting, say, 5 pounds of pressure on them, something reasonable, plunge it into water and see if you got bubbles coming up. Just double check it. All right, what do you guys need to see today? I have on my list AFR tuning. What else do you need to see so that you can go home and say, this is exactly what I needed? Yes, sir?
On-road test.
Pardon?
On-road adjustments.
Okay, on-road adjustments. I am taking vehicles out one after another, and I'm going to try to grab different group every time I go out. I sit in the back seat, if applicable, the Ford Ranger. One person will drive, and one person will be monitoring the scan gauge. and doing the actual adjustments as we go. So it's a communication between the two. The two of you, your minds become one functional machine. I just ask questions and prompt you, but get you thinking on your own. I want everybody to tune. You're watching the tuning on the dyno. I want all of you out on the road before we go. So that is a priority that I have here. Road tuning. What else?
I just have something to say. When I went to the first class, we had somebody here, and I won't mention names, he's a nice guy and everything, but he wanted to see that fuel cell make mileage, that's all he cared about. And you came over and you said, what are you doing? He says, I'm waiting for a bracket. He said, well, why don't you use one of the things in the back of the book and put one of them tricks on while you're waiting? And he argued with you, and he says, I don't want to put a trick on, I want to see what that fuel cell does, because that's what I paid $1,000 for. Well, today proves that you can make all the water gas in the world, and if you can't tweak that oxygen sensor or that MAP sensor so that the car knows how to use it, you're not selling a fuel cell, you're selling gas mileage.
Right, you're not selling a
Tricks
fuel
in the
cell,
back of
you're
the
selling
book
fuel economy.
Will help you get that fuel cell tuned, that car tuned to burn the water gas that fuel cell is making. See, it's a whole concept of how you're looking at this thing. Everybody thinks you're going to put a fuel cell on, and you're going to get 1 million miles to the gallon or whatever. If you can't make that car use that water gas properly,
You're just building horsepower. We're getting the same amount of fuel that the car was originally injecting, plus we're injecting something that's got 5 times the potential. So it's like putting a little bit of nitrous in a motor. That's all we're doing. We're not getting any miles per gallon gain, we're getting horsepower gains. That's the whole idea. Is I don't know if I've done so many cars, but I know I had quite a few on the dyno that you could literally hear the engine. We would put a steady throttle on it, and as I was tuning, you would hear that engine, oh, just that steady throttle. I mean, if you don't got a dyno back home, I don't think none of us do, put your cruise control on. We want to get that idle or the throttle steady, so while you're tuning, you can hear and feel what you're doing. I mean, also with your meters, and you got to try and get that happy medium area going on. And if you can do that, I mean, that
There's ads in D-Sport, Modified. I think there's 5 different tuner-type magazines that Dutchman is running ads in, so that's on our list of things that we're working on. But yeah, sell them to hot rodders. Anything else that anybody would like to see more of? Yes, sir.
How to adjust the MAP sensor,
How to adjust the MAP sensor?
and how to determine whether we should be messing with the MAP sensor.
Okay. Does anybody else here have that same question?
The MAP sensor?
Yeah, using the map adjust. When do you use it and how do you adjust it when you use it? Okay, I put that on the list. We'll go over that. The red Oldsmobile has one on, is that correct?
Yes.
Okay, so as a group, when we get that one in, if that's on your list of questions, be in there in the dyno room and we'll go over that. We'll try to do that one on the dyno.
well, especially if you got an oxygen sensor that's giving you trouble, like Mike said,
Mm-hmm.
you go to the MAP sensor because that's a big sensor for
fuel control.
fuel control.
Right, but it also affects spark timing, because like he said, he was getting detonation issues and had to go and counter. It's like you're taking 3 drugs, one for the problem, one to counteract the symptoms for this one, and then a third one to counteract the symptoms for that one, and hopefully your blood pressure doesn't go up later. Okay, what else do you want to see this afternoon? I have tuning AFRs, going out on the road, translating dyno to road tuning, and I have more on using the map adjust circuits. Does that fit everybody's bill? Yes, Keith?
And also tuning a car that isn't as sophisticated as the newest ones are.
That Oldsmobile.
Carbureted.
Yeah, you're talking carburetor, you're talking fuel injected. I think that Oldsmobile would probably fit that bill. It's like a late 80s. Pardon?
There's no live
There's
data.
no live data on his, you can't hook into that and get any live data.
That's probably like a late 80s, right?
No, it's 92.
92, but there's.
And it doesn't have data stream?
Yeah, well,
Maybe if you
I
got
didn't have it
Asian
connected
software.
with my scan gauge, and
The Mac Tool
There is no-
scanner here has the adapters for 92, so you can pull data stream up.
And they may not give you all the pins on that either, you have to look and see what they offer,
Yeah.
they don't always offer all.
Yeah. Anything else? Okay. Is there a determining factor when you would even use a map adjust type of a circuit? The map adjust circuit will allow you to lower your lean limits. If you have a vehicle that you cannot raise the coolant temp much at all before you start kicking cooling fans on, we have one out here. Or if you have a vehicle that has no air temp sensor, or whatever, and you start leaning out the oxygen sensor, it's a known good oxygen sensor, because if it pops into open loop a lot, it could be a bad oxygen sensor, but let's say it's a known good one, it was just replaced, you know it's good, and you start leaning it out, and you got all kinds of power, but it starts popping into open loop on you. Your lean limits are too high. You've exhausted the normal things. Your coolant temp's as high as it gets anymore, and you've got a cooling fan continuously running. You have no air temp on there, but you do have a map sensor. You got to lower your lean limits so you can cut back on the fuel some more. Good candidate for a map adjust. You have a vehicle like the PT Cruiser, where the oxygen sensor circuit portion is very limited, and since we're going to pretty much gut the optimizer by raising the grounds, we can't use any of the other features on it. Well, the map adjust now gives you another way of cutting back on the fuel. Now you can tune the oxygen sensor, don't have any lean limit issues. Or ignition timing. By lowering the VREF going into the map sensor, not only do you lower your lean limits, but you advance the ignition timing. If you start going in, lowering your air temp to advance timing, and then it raises your lean limits to where the two conflict, well, then you can take and put your air temp back up, go and start lowering your VREF into your map adjuster, and that'll advance the timing. Or you could go in and raise the voltage going to your map sensor to retard the ignition timing if you have other ways of keeping your lean limits in check. It's just another tuning tool, but again, that's a good question. What we want you to understand in this class is stuff like that. When do you need a map adjuster? How do you know when you've got it? Define what the target is and know when you've been able to achieve it. And if you have lean limit problems, map adjust. If you have a vehicle that's very restrictive on what you can do to it, a map adjust may be your saving grace.
Wouldn't a map adjust just about to be 10 times out of 10 then?
Go out here and count how many vehicles in this lot use a map sensor that we can adjust. And what you'll find is a lot of them are using mass airflow sensors. Now that map adjust is not going to work on a mass airflow car that puts out a frequency signal. So it's not applicable to all vehicles.
Internally in the optimizer, all of the components are wired to a common ground.
Internally in the optimizer, yes, there's a ground bar, as it were, to where the entire circuitry is grounded. Now, on the 4X, there's going to be there's going to be two exceptions to that. But on the 3X, yes, everything shares a common ground. Jerry?
I think another parameter in answer to his question
Uh-huh.
is the lean limits that you're watching on your scanner. You want to know, well, how do I know whether to do it? If you're watching your lean limits and you're not bringing them down, then you maybe decide to do another trick.
Okay, now you say watch your lean limits. That would essentially be it keeps popping into open loop on you while you're trying to tune it, right?
I'm sorry, long-term, short-term fuel.
Oh, okay, long-term, short-term,
That you're
yeah.
subtracting fuel. If you don't see that you're subtracting fuel, you gotta keep going.
Right.
You know what I mean? If you did one thing and you're watching that and you're still.
Don't overdo it.
Right.
Yeah, I mean, if you're in closed loop and you're cranking, and you're not seeing the negatives, it's not responding. So maybe you should look at something else. We had that Toyota Camry going into closed loop. We had that Toyota Camry kicking no codes, but we disconnected the oxygen sensor on it and it still didn't trip any codes. It brings to your awareness, hey, there's a problem here. I'm leaning it out and it's not responding. Any other questions, comments, or sarcastic remarks? All right. I'm going to be out doing road testing. I'm going to take a car out with a group. We're going to tune it, bring it back. Going to grab another car in another group. Go out, tune it, bring it back. Grab another car in another group. Mike's going to be working the dyno. Back it out, bring in another one, tune it. When we get to the Oldsmobile, watch that Oldsmobile. If that's something you want to see on the map adjust, and Mike can take a little extra time and make sure that everybody understands the whole principle behind it while you're doing it. Does everybody understand how to build one? You all have a copy of both circuits, right? And I've seen quite a few people. In fact, if the camera goes over here now, you'll see that we have soldering iron. We have everything set up where we've got students building them at the end of the table. That's good. That's what I wanted. You now have the experience of building a map adjust.
Awful lot of wire you got there.
Yeah, so this is where you can sit in the back seat and tune the map adjust from under the hood.
I kind of like the student driver with the extra set of pedals.
Yeah. Okay, let's go to it.